For each principal energy level, we have a prescribed number of sublevels. Remember, principal energy level 1 has one sublevel, and we always start back with S every time we refill. So if we only have one sublevel, then that sublevel will be 1S. If we have two sublevels, then we're going to have 2S and 2P. 2 indicating that we are in the second principal energy level, S and P indicating that we are in that orientation, first the sphere and then the figure 8. So if I had 3 sublevels, which ones do you think they would be? 3S, 3P, and 3D. Perfect. Good. Fourth sublevel would be 4S, 4P, 4D, 4F. So one thing we do need to memorize is this order of orbitals filling. So it's S, P, D, F, G, H. I had a student a long time ago that told me that she remembered it as some people do forget going home. That's a pretty silly sentence. It's almost as bad as my kitten doesn't call me Mr. Nano Pico, but just the same, some people do forget going home maybe helps you to remember SPD, FGH, or maybe you just say to yourself over and over again, SPD, FGH, SPD, FGH, and you learn it, okay? But you've got to learn that order because in our fifth energy level, we would have 5S, 5P, 5D, 5F, you got it, 5G. And in our sixth energy level, we would have 6S, 6P, 6D, 6F, 6G, 6H. Very nice. So you would think, and you know it's always trouble when someone says you would think, right? Because that means I'm going to tell you otherwise in just a minute. We would think logically, if the atom would just be logical with us, we would expect the order of orbitals to fill just straight down this line. 1S, 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F. Just straight down the line. 5S, 5P, 5D, 5F, 5G. We would expect that, but no such luck. In real life, IRL guys, the electron paths start to overlap. It's not so clean and easy. Remember that the quantum mechanical model is known for its convoluted nature, that this is not just the simple Bohr model. This is a real life version of what is happening, what we actually see occur inside of the atom. So let's look first at what the real order is, and then I'm going to teach you how to memorize that real order without having to memorize anything. So as we look at this structure of the atom, and so remember that our nucleus is down here. Okay, we have our nucleus down here. 1S fills first, and then 2S fills, and 2P. But as we start to branch at 3, notice that if we keep going up, 3S, then 3P, and then 4S actually overlaps and comes before 3D. And so we start to get this kind of strange overlapping happening. And this could be like really brain burstingly confusing, except someone came up with a great way to memorize this. It's called the diagonal method, and I'm going to show you right now how to know exactly how the electrons fill. To do the diagonal method, the first thing you need to do is you need to write out the order of the orbitals as you think they would fill across your page. So each of you needs to get like a pretty good sized piece of paper right now. Maybe a half piece of paper would be pretty good for this. We're going to start by writing down the order of the orbitals. So we start with 1S, because that's the first orbital. And then in our principal energy level 2, remember we have 2S and 2P. Then we have 3S, 3P, 3D, 4S, 4P, 4D, 4F. Remember what comes after F is G. So we go 5S, 5P, 5D, 5F, 5G, and then 6S, 6P, 6D, 6F, 6G, 6H, and we'll stop there for now. So now what we're going to picture is a little cupid, He's Cupid because he has some wings. And Cupid has a bow and arrow. Okay, because that's really what we need right now, is we need a bow and arrow. And so we're going to shoot from this upper right-hand corner, and we're going to look at what orbitals we hit. So we're going to take this one first, and the very first orbital that I cross paths with is 1s. This is the actual order that the orbitals fill. So what we're putting down here is the order that the orbitals fill. Okay, we're going to be filling orbitals for a lot of this chapter, so it's important that we know what order they come in. So 1s, and then we're going to take another one here, 2s, and now 2p followed by 3s. So when we draw an arrow through multiple rungs, we consider which one did it hit first, 2p, and then which one did it hit second, 3s. We write that down. And now we shoot another one, 3p here, followed by 4s. Now we shoot another arrow, and this one's going to hit 3 different groups in a row, 3d, 4p, 5s. We write that down. 3d, 4p, 5s in the order they were hit. 3d, 4p, 5s. Another through here, and we get 4d, 5p, 6s. We're getting pretty low on the periodic table now, and I'll show you that in a minute. We need a 7s, so we're just going to put it in here. So we're going to draw our line through, and we're going to see 4f, 5d, 6p, and 7s. And we're going to go ahead and stop here with our orbitals filling for now. This one continued on through 5f, but I'm really not going to take you much past 6p. That's going to be about the end of where I'm going to take you. So this is the actual order that the orbitals fill. If we were in live class, if we were back at Bishop, you would have a quiz on this tomorrow. You would need to be able to, off the top of your head, create this diagonal and create this list. Now, the reality is that you guys are at home, so you're not going to be tested specifically on can you create this order of the orbitals, but I will tell you now that you have to know this order of the orbitals. So whether you write this on the top of every piece of chemistry paper that you have between now and the test, or you learn how to use it in the periodic table in your book, or whatever you're going to do to know this order, you absolutely must know this order in order to continue in chemistry.